Mean and median are measures of middleness. Let's talk about measures of variance. They describe the spread of the data set. So we're talking about range, interquartile range, variance, and standard deviation. And in this lesson in particular, we'll focus on standard deviation and the statistical mean, so simple average. Now in general, variance describing the spread of the data is found by taking the average of the squared differences from the statistical mean. And the reason why you square the differences is so that they are positive and that you get a positive description of how the data is spread out from either side of the mean. Sigma squared denotes this, and we will be using standard deviation. Standard deviation is going to be the square root of the variance. It is denoted as sigma. So you could write it like this. It's most common and useful. Now, low standard deviations indicate that the data is clustered near the middle. High standard deviations, it's spread out. So if most students get between an 80 and 100 on the test, that standard deviation is going to be low because the data is clustered closely together. But if you have scores ranging from 30 to 100, then you're looking at a higher standard deviation. Speaking of getting a 30 on a test, you would assume out of 100% that's not going to happen very often, and that's known as an outlier or an extreme value that is much less than or greater than the other data values. So outliers have a strong effect on the mean, so it tugs it toward it. It also affects the standard deviation because it's giving a false sense of how spread out the data is, because the outliers usually don't occur very much. Hence, that's why they are not a true, like if you have outliers, then it is going to distort what the true sense of middleness of the data is. In this class, the way that we will decide if something is an outlier or not is by seeing if it is more than 3 standard deviations from the mean. So we have x bar, and then you're going to minus 3 times sigma, and any value. So 3 standard deviations to the left, or 3 standard deviations to the right, x bar plus 3 sigma. Any value outside of those two numbers, below or above, will be considered an outlier. So if we look at our graph here, which is a representation of normal data, which we'll talk about in another lesson, you can see that each of these is a standard deviation away. So to the right, 1 standard deviation, to the left, 1 standard deviation. 2 standard deviations to the right, 2 standard deviations to the left, where that curly symbol sigma is present. And then if we are all the way 3 to the right, so there's that idea of 3 to the right, or 3 to the left, there's the idea of 3 to the left. Anything outside of those bounds, so here and beyond, so greater than x bar plus 3 sigma, and all the way over here, less than x bar minus 3 sigma, you're looking at an outlier. So these outliers, as you can tell, really, if you add up the two ends here, outliers account for about 0.2% of the data. So they're really not characteristic of what's going on in your data set. Let's look at an example. In manufacturing, things don't get produced precisely every time. So they're going to vary a little bit. So the can height in millimeters, I'm looking at a lot of 2.8s, 2.9s. So maybe the mean is about 92.8. So that's what we can expect to happen. But there's some spread in the data. Sometimes it's a little below that number. Sometimes it's a little above it. So to use a free online resource, what you'll do is input all this data separated by commas, using the link in the assignment sheet. With all the information entered and pressing calculate, you're going to find your X bar. So it's about 92.8. I guesstimated that it was going to be around there, and it looks like that's the case. And here's your sigma, the standard deviation. You have a sigma of about 0.2. Variance, don't worry about. And hold on, standard deviation and population standard deviation are different. We do not want to look at just the regular standard deviation. We want to look at the population standard deviation. So our sigma is going to be approximately 0.19. And the variance, population standard deviation, we will not pay attention to. So use the mean and the population standard deviation as your X bar and sigma respectively. So going back to the note sheet, what we'll do now is realize that X bar plus 3 sigma will equal the X bar of 92.77 plus 3 times our sigma, which is about 0.19, .34, and then to find the other side, we'll do X bar minus 3 sigma, and that is 92.77. So we're always starting from the middle and then looking 3 standard deviations to the right and then looking 3 standard deviations to the left. And this sums out to be 92.13. So anything that is greater than 93.34 is an outlier. So I'm looking at the data and nothing is above 93. So we're okay there. Now anything below 92.13 is an outlier, and we have a 92.1 right here. So that's an outlier. And this justifies it. So we found the mean and the standard deviation, and we identified any outliers. What you should also do in practice when you identify an outlier is to run your data again, but then take out the outlier. And when doing so and recalculating, you'll find that your X bar will now become about 92.82 millimeters for the can height, and you'll find that your population standard deviation will be about 0.08 millimeters. So notice with when you remove the outlier, you get a better sense of where the middle actually is, 92.82, as opposed to this, pretty close. But notice now with your standard deviation, which is a measure of the spread of the data, it has changed significantly because you have taken out a number that's really far away, specifically more than 3 standard deviations from the middle, classified using X bar.